Okay, let me turn it over to Rob to present today his talk.
Thank you.
Okay, Rob, handing you control.
I think I have it. Right, so people should now be seeing my title slide, I hope.
Yes.
Excellent. Boy. Is there a way to minimize the control panel?
Yes, the little orange arrow.
Oh, there we go. That's it. Yeah. Okay. So thank you everyone for coming to the presentation. Yeah. So as introduced, I'd like to talk a little bit today about using linked data and images for cultural heritage institutions and particularly, of course, museums. And yeah, thank you also for bringing up MCN because we have a session on the schedule at MCN about AAAF. I unfortunately won't be there, but my colleagues from here at Stanford and from Princeton will be talking about AAAF. So I very much hope that you can attend that session. Okay, so the starting point that we have come from is that images are fundamental information carriers for all sorts of cultural heritage. So it doesn't matter whether it's an archive or a library or a museum or a gallery. It tends to be that if you are sharing your content via the web and via linked data, that the richest way of interacting with that content is via images for the everyday user. So on the left here we have the chessmen, the Lewis chessmen from that person could mute to this join. Thank you. Okay, so on the left we have the Lewis chessmen from the British Museum, and on the right a manuscript page from Beinecke at Yale. And the reason that I bring these two very disparate objects together is simply to show that you can get a very good experience about what the object is that you're looking at via an image, rather than simply a text description. The issues that we run into, of course, is that digital image delivery is pretty hard. You know, it's currently ugly, to put it bluntly, in terms of both the technology, the image servers don't do a particularly good job, and the context around the image of our beloved objects isn't often the rich digital experience that we would like to offer our users. It's often very slow to get access to full, high-res images so that you can really interact with the content. It's complex at the end of the image server, the museum, to get things set up so that you can have a rich experience with the images, with zooming and panning and so forth. The reason, because it's complex, it's currently also too expensive. The licenses for deep zooming image servers can run tens of thousands or more dollars per year. And the images are often too disjoint from other content. We're talking about linked data, so where are the links? You can't have a link in an image, clearly, So we need to have the context about the object that's being depicted in the image associated with that image in as rich a way as possible. So for these reasons, everyone suffers. So the content owners suffer because they have to either pay lots of money or devote lots of resources to getting the images to be visible. And the user suffers because they don't have this rich experience due to the previous problems. So we looked into this situation, and particularly in the manuscript world was our initial focus. And we found that there was this world of duplicated effort across the board. So everyone had some page turner or some way of interacting with images, and they worked with their own particular image server, but every site was a silo. So you couldn't go from one site to the other. You ended up stuck within the single site. Every application was something that everyone custom built for each particular collection, so that you then ended up with this sea with islands and no bridges between them. Where those islands are the applications. You have to maintain all of your little islands separately. So it mounts, the cost mounts for every app that you build. And then also the users, of course, are forced to relearn the interfaces for all of the different applications. And this is particularly noticeable when you go to one of the large cultural heritage aggregators, like the Digital Public Library of America. I know that Tom Johnson is next on our docket. It should be very interesting. Or Europeana. So if you do a search in either of those aggregators, you can see sometimes a thumbnail, but then when you want to interact with the object, you have to go out to the individual cultural heritage institutions interface and learn every time a new interface for interacting with that particular content. So, of course, there is a better way, in our opinion. At this point, I'm going to quickly jump out and show you what we think is this better way, rather than tell you. So hopefully you can now see my web browser with a black screen that says Add Item to Workspace. So this is the Mirador client that we've been developing here at Stanford. And there are other clients. The Wellcome Library in London have developed a client. The Internet Archive book reader is also capable of reading information in AAAF. And there are several others, but this is the one that we've been working with here at Stanford. So we start with the blank workspace, and we can add things to it. So here I've used the Lewis chessmen from the British Museum as a set of items, and we can scroll through and say, okay, maybe we want to look at this guy. And these won't zoom in very deeply because these are just the images that are publicly available on the web of the website of the British Museum. I'm sure they have much more high quality images that they might be able to make available. So we can also compare objects rather than having a single object. So maybe we want to compare a couple of chessmen, say some of these knights, this guy and this guy. Get rid of those thumbnails. So already, I think you can see that with a little bit of technology at the back end, it's becoming quite a rich experience where you can compare and contrast content. We're not losing any of the information from the site.crm description. We have the label, the description, the exhibition history, and so on and so on. switch back to a single workspace. And as promised, so these descriptions aren't public. They're only on my local machine. The reason for that is that, of course, I'm not the copyright holder for any of these images, so I don't want to get in trouble with anyone. But so, for example, here is some images which can zoom more deeply. Which doesn't have as much information. And we could compare them in the same way. And some more from YCBA. Or perhaps from the Fitzwilliam Museum. You want to compare, switch back to compare. With something, so this on the left now comes from the Fitzwilliam, and on the right comes from the V&A. And yeah, as previously, these images are just the ones that are currently available publicly on their websites, rather than any particularly high quality images. So to show you what we could do, so this is a collection of coins that we've just digitized here at Stanford, which are a bit more sort of museum object focused. And again, we can have all of the rich description of the coin, its bibliography, its number, what the inscriptions are on the reverse and obverse sides.
Rob, can we ask you a quick question?
Sure.
So just this is extremely interesting. Just to be clear, you're able to pull all these things together because they are published as linked open data from the museums, or from the
Yep.
Yeah. Okay.
Yeah. So from the Yale Center for British Art and the British Museum, it's transformed from the SciDoc CRM interfaces that they provide, and from the Fitzwilliam and the V&A, they don't have linked data, but they do have APIs available to get to similar information. Okay, so hopefully that's enough show to get the feeling for what I'm going to talk about further. So how does that work? So that's what I'm going to try and explain for the rest of the presentation. So I know I'm preaching to the converted, but by using linked data and APIs to get at things like the images, we can enable the reuse of content across systems. So all of those images and descriptions were coming from different sites and can be pulled together in the browser into a single interface. So without this middle layer of linked data and APIs, we couldn't do that. So this is what it really looks like now, where the red application 1 can talk to all of the different servers. The green application 2 doesn't just talk to its green server 2, it can talk to all of the other colored servers via this shared layer of linked data. So the IIIF community has a vision statement of where we are intending to go. So what we'd like to see is a global framework of interoperable servers, so both the images and the linked data descriptions about the objects for those images, that serves out hundreds of millions of images, and we're quickly reaching that number actually. from leading cultural heritage institutions, such as yourselves, but also libraries, archives, and galleries. To best of breed clients, so we already have Mirador and the Welcome Player, and several other clients that are coming online soon, so that the user has a choice of interface that they feel comfortable using to interact with the same content. And that's really the strength of using linked data and the APIs, that you can make that choice rather than being stuck with whatever the application that the content providers have chosen. Those clients should do viewing, manipulation, and annotation of the objects, so that you can, of course, see them. You can manipulate the images to zoom in deeply, and you can increase the value of those resources by annotating useful information onto them. And this should be available to anyone online. So that's the vision statement. That's where we want to get to with all of your help. So what is AAAF? The million-dollar question. So AAAF is three things, and I'll go through them in order. So first of all, it's two linked data-based APIs. So we have the image API, which allows you to interact with the images, so you can get the pixels, and it has technical information about those images using linked data. There's also the presentation API, which has just enough description to drive a remote viewing experience of some object using linked data. So I'll come back to the presentation API in a moment. The image API first allows you to do these sorts of things. So you can start off with a full image, such as the one at the top. You can select a region of that image. You can then say, I want that region at a certain size. You might want to mirror or flip the image. Maybe it's important to rotate it, and then you can ask for it at a certain quality. So should it be in color, should it be in grayscale, black and white, or should it be compressed? So a bit of a technical slide, but just to show you that it's pretty straightforward to use this API. We just have URL templates into which we put those parameters. So the top one in the list is how you would get the full image if that was available. So it's the full region, so the entire image, it's full size, there's no rotation, it's in the default, so hopefully color quality, and in JPEG. The second one then says I want a region which starts at coordinate 100 by 100 and then is 640 pixels wide and 480 pixels high. The third one says I want it at 640 pixels wide, so that would be the full size. Or the one below that says I want it at half size, so at 50%. Exclamation mark is how you do the mirroring. 180 is how you do rotation. Then the last two simply change to grayscale or from a JPEG to a PNG. So if you have a web browser, you could use the image API directly. Or if you have a client that can construct those URLs for you, then you can do things like pulling out tiles of an image, putting them together to get that smooth zooming experience that we have with OpenSeaDragon and Mirador. So that's enough about the pixels. So where's the linked data? I hear you all thinking. So for the image API, not only do we need to get to the actual pixels, we need to know about the image in order to use the pixel API. So for example, we need to know that the image has a height of 6,000 pixels and a width of 4,000. Otherwise, we wouldn't know how to divide it up to get those tiles. We then have a few more properties, such as at which scale factors you can get the image. So 1 is full size, 2 is half size, 4 is quarter size, and so on. Sizes lets you say, you can get images at these explicit sizes. So you can get the full image at 10% of the size, so with the 400 and height of 600, or at 50%, where the width would be 2,000 and the height 3,000. And profile just says, this is the functionality that my image server supports. So this, I apologize for the curly brackets, but just hopefully to show that linked data is useful outside of just describing the context of the object. And you may think, hey, that doesn't look like any triples or linked data that I've seen. The reason for that is we're using JSON LD, and I'll explain that in a bit. So the presentation API is our other technical side. And this has just enough information about the object to display it to a client. So there's descriptive information, there's the structure of the object. So for the statue that I was showing at the end there, here is the different views. Or for a book, it starts at page 1 and ends at page 650. The layout of the content. So how does each page exist if you have more than one resource concerning that particular page or that particular view of the object? There is, of course, attribution and licensing information, critically important, and links to other resources, linked data. So I said that there were 3 things that AAAF is. The second one is community, and we find this is at least as important, if not more so, than the technical side. It's no good having great technology that no one adopts. So we're pleased at the current uptake, and we have 9 or so national libraries, a bunch of high-profile research institutions, all of the major aggregators in the cultural heritage sector are invested in AAAF, so ArtStore, DPLA, and Europeana, and several projects including Biblissimo at the BNF eCodices, which, if you don't know about it, is essentially the virtual manuscript library for Switzerland, TPen and TextGrid. So you'll notice that we don't have a museum column there, and that is something that we would very much like to change. AAAF Discuss is our discussion list, and yeah, the number of members is growing, and we hope that continues to. And you can join by going to that URL there at the bottom, and you can get there from the AAAF site. The third thing is it's the software that the community has developed to implement the technical specifications. So we have various image applications, which I mentioned. There's also clients that work directly with the images. So OpenSeaDragon is embedded within Mirador. OpenLayers is used by the map community quite regularly. IIP Mu Viewer comes out of the IP image server, which is from Reuven Pillay at the Louvre, and FSI Viewer. There's, of course, also the image servers. So Loris comes from Princeton, and IIP is from the Louvre, as I said. And those are both very solid implementations of the most recent versions of the specifications. So why why should we use AAAF? What's the benefits? So just to walk through them quickly before going back to a little bit more information about the linked data side of things. So rich image delivery is something that, in our experience, everyone wants, but has had a hard time actually putting into practice. The zooming, you can explore an image in a very detailed way without consuming vast amounts of bandwidth or giving up the availability of the entire image all in one go, is something that it's very useful to have someone build once rather than everyone having to implement by themselves. Which brings me to the second point, the plug-and-play software. By using linked data and APIs, we can simply take any conforming image server and any conforming application and use them together. So we're escaping from those silos of content. Publish once, reuse often. So by this I mean we can put our images online, we can put the descriptions of the objects online, and they can be used in all sorts of different contexts in ways that we might not have imagined. We don't have to create new versions of things just to have it used in a different context. We can remix content. So one of the, of course, interesting things about the Lewis chessmen is that they're divided between at least the British Library and the National Museum, the British Museum and the National Museum of Scotland. So wouldn't it be great to pull those collections back together virtually, if not physically, so that you can look at all of the chess pieces as they originally were. The same, of course, happens in archives, where some person's collections get given to multiple archives. And in libraries, it's particularly bad when manuscripts are disbound and distributed leaf by leaf around the world. Cite and share. So because there are stable URIs, because it's linked data, you can say, I'm talking about this object, I'm talking about this part of the image, share it with your colleagues, and they will be able to see exactly what you saw. It's annotation friendly. We want to engage with our users and have them contribute content or thoughts about the resources rather than just be passive viewers. Attribution and access control are, of course, important. We need to know that this image comes from the British Museum or from the National Library of France or wherever it comes from. Access control is something that we are actively working on at the moment. So if you need to be logged in or registered in order to see the full size of an image, for example, that needs to work across the ecology, the ecosystem, such that you don't have to log in 16 different times for 16 different servers. And of course, being part of a global network has its advantages. Your content is out there in a controlled fashion with all of your peer institutions across the cultural heritage sector. So it's really, we find, better to go together down the path rather than everyone trying to forge their own way through the jungle by themselves. Okay, so back to the presentation API. The presentation API, actually, at this point, are there any questions from anyone about the content that I've gone through so far? I should have paused earlier, my apologies. Nope, I shall get going. So the presentation API is really the space where we have the most linked data in AAA. So the goals for the presentation API are to drive a rewarding user experience so that when the user comes to interact with the content, they feel like it's something that informs them and hopefully impresses them. It should be independent of the domain. We want this to work with museum content, library content, archival content. Wherever there's cultural heritage resources online, it should be able to help with getting those resources to the users. It should be easy to build applications and to reuse applications that implement the software, the specifications. It should be distributed on the web. The web is our humanity's greatest information system, and gives us access to everything without having to travel. So building things as part of the web architecture seems fundamental to us. And of course, it plays nice with others. So it should not try to replace SciDoc CRM. That would be crazy. It should not try to replace the equivalent library standards. We want to do this by describing several things. The cultural context of the object being displayed. So, this chessman was in these exhibitions, it's made of this material, it's this size, it was discovered at this site, and so on. The structure of the object, here are the different views, the layout of the individual views, the reuse rights and requirements, and links to other resources. So we started by looking around at the various options. We don't want to reinvent something if there's already something which would fit our needs. And of course, there are many standards that would claim to do this sort of thing. And this is a poster made by Jen Riley of some of the cultural heritage sector's standards for doing this sort of thing. As you can see, the text is far too small to read all of the individual specifications. So, of course, this is rather disheartening. It would be great if there was one standard that we could all agree on, which will be very tricky. So, rather than give up dejectedly, we decided to change the rules of the game. So instead of trying to focus on the object, so let's describe the object in as rich a way as possible, instead we wanted to focus on the user experience. So this is why the presentation API isn't a metadata description in the traditional way of SciDoc CRM and so forth. So it's only the information that's necessary for an application to present the object that it's describing to the user. And you'll see in a moment why, where this distinction starts to matter. And for the technically minded, there's the URL to the specification. So we start with a data model called shared canvas. Now, this is an abstract space which we use to build up a view of the object, which sounds airy-fairy and complicated, but just think PowerPoint slide. So you have a canvas or slide, and it starts off empty. You haven't built out your presentation at all yet. And maybe you want to drag and drop an image into your presentation or onto the canvas. So all of those images of the pages and the chessmen and so on were being added to the canvas for that particular view. The reason why we want to then do this is that you want to also associate other information with parts of the canvas rather than with the image. So you might want to add text to your slide or canvas, such as the transcription of the page. So you could delineate some regions within the canvas and say, this is the text that appears at this point. And we've talked about annotation as well. So you also probably want to have users be able to comment on various bits and parts of the object or hints. We want to associate those with the canvas as well. So we're really trying to build or create a focal point for all of the information about that particular view of the object, rather than associating it directly with the image. So why would we do this? Why don't we just associate things directly with an image? So there are several reasons. Hopefully the clearest one is that you can have one canvas, the focal point, but multiple images that are associated with it. So this is part of an image from the Archimedes palimpsest, and for every page there is on the order of 25 images taken under different lighting conditions. And using computer techniques, you can merge those images in order to see in that bottom right image the text that had been erased in the 13th century and written over. So those three images are all of exactly the same region of the page, just with different techniques applied to them. So the top is a 13th century text, the bottom is Archimedes' original text that was erased. So if we had to associate information with the images, we would be associating it with all 25, and that would be a nightmare. So hence we can associate it once with the canvas. The flip side is also true, that there can be one image that depicts parts of many canvases. So here are some fragments of manuscripts, and you can imagine bits of tablets or statues or other sorts of objects that are collected together in a single image, but should be associated with different canvases. So the middle piece of parchment there is probably from a different original page than the one at the bottom. And it's not just images that we're interested in. This is a flyleaf from a manuscript in the Parker Library in Cambridge. And it was used or recycled from another manuscript, which was about 300 pages long. And this is the only page that survives. But it has some very early English music. This music has been performed many times and recorded. And you could go to the presentation API in an application and say, please give me this image for this page with the transcription of the lyrics and also the performance of the music. So using HTML5 and other technologies, we can deliver a much richer experience directly to the user than you could even by interacting with the physical manuscript. Okay. So the structure, so that's the layout side of things. The structure is relatively straightforward. We have content, so the images, the music, the text, and so on, which is associated with a canvas, which is the blank PowerPoint slide that we use as the focal point to bring everything together. We can then have a sequence of these canvases. So start with the page 1 in the manuscript case, or the north view of the statue, and rotate around it. That sequence is associated with a manifest, which is the set of all of the information about a particular object. In this case, a manuscript, but the statue or the chess piece. That can be part of a collection, so 4 different manuscripts, or all of the Lewis chessmen. Collections can also be part of collections, so that you can have a rich hierarchy that you descend down. So here is all of the knights, or this is believed to be a single set of chessmen, as part of all of the set of chessmen. Of course, we have to have a description about the object. And this is where the difference with other linked data approaches is most apparent. So we have a very small set of descriptive properties. So instead of having however many numbered properties, such as inside of CRM, or 1,600 properties, and RDA in the library world, we have just 4. So label is the name of the resource, so the name of the collection, the name of the object, a name for the view, the canvas. A description about the object or about the resource, which we think of as a textual summary, a thumbnail, so an image summary, and then metadata. And metadata is a big pool of labels and values that get displayed about the object. So this is how we can have information about those coins, like inverse type and obverse inscription, without having to introduce many properties. So the label would be obverse inscription, and the value would be the inscription itself. Equally, it could be when it was created, it could be the exhibition history, whatever you want to display to the user, it goes into those pairs of label and value. So yeah, this is why we feel that the presentation API is not just another standard in the same as all of those other 150 standards that Jen Riley looked at. Those are trying to do descriptive information at a semantic level such that computers can do reasoning and so on. Whereas the presentation API tries to live in a different world. We want to keep that information, but provide an easy way using linked data for viewers to get to very quickly the set of information that they should present to the person using the application. Okay. Rights, of course, very important. So there's the license, which you can associate with any of the resources. So a collection might have a license, an image might have a license. And then 2 fields which are equivalent to the thumbnail and the description, attribution, which is text which we require any conforming application to display when they use that resource. So if you attach an attribution to an image, then the client must display that attribution statement. And a logo, which is the same as equivalent to thumbnail. So this is an image that the client is required to display when using the content. And we have various linking properties, services to enable richer experiences. See also, which is here is the SiteUp CRM description. So if you do understand the community specific information, you might be able to go and find more information to work with. And related resources that you might want to display to the user along with the object that the presentation API describes. So for example, if you had a video about the chessmen, then you might want to relate that video to the object. So it's not a depiction of the chess piece, it's information about it, and hence the linking here. Briefly, how does this work? I've already actually said it. I gave myself away. We use JSON LD, which is very easy for developers to work with. It's what JSON is what practically all web applications are built on nowadays. But it's also linked data, so it plays nice with others. We can link from the presentation API to SiteUp CRM descriptions. We can link from one object to another, and so forth. We've already seen some curly brackets. This is what a canvas would look like. So it has a label, page 1. It's got a height and width. It has some images associated with it. And it might have some other content, such as the annotations and the transcriptions. So, and I think I'm doing pretty good for time. The summary. So IIIF is 3 things. It's the technology, so the APIs, images, and linked data. It's software that implements the technology, and it's the community that adopts and develops that software. And we would be very happy for any and all of you to be part of that community. Linked data is used within IIIF in several places. It's used to describe the technical metadata about the images, so the height, the width, scale factors, and so on, and also to describe the digitized cultural heritage objects, their cultural context, the structure of the object, the layout of the individual views, rights and reuse statements, and relationships to other resources. So thank you very much for your attention. Some links that you can play with. So AAAF.io is the main website, the two APIs, technical descriptions if you're so inclined, and the Mirador 2 test instance that we have up on Soul Reader Test there if you want to go and play with it further. So I hope that there are some questions.
Well, Rob, I have a couple of questions. This is Eleanor. Thank you ever so much. We're all sitting here jumping up and down while you were presenting. Because in essence, you have presented what we were considering as, you know, if we go in the direction of a federated model as opposed to an aggregation model, how would people, what are some of the possibilities for accessing information? And we even had a question, I don't know if you're with us, from Princeton, there was a question along these lines about accessing and retrieving information. But what you've shown us is that this would be one way. This would be a possibility for the American Art Collaborative to consider. If it's a year from now and we've published our data, this is one thing that we might be able to consider through you, through this organization to distribute our data. Is that correct?
So yeah, the model that we have in mind is that for the distribution of the content is that the museums and other cultural heritage institutions are the best place and the most important place to look after their own content. So we don't have an aggregated system like ArtStore where you send everything off to a central place. Everyone chooses how to be responsible for their content.
Right.
Which is not to say that everyone has to implement everything themselves, of course. There could be collaborations that host images, sort of for a set of museums. Or there's also, but we hope that people will do it themselves. And one of the goals for 2015 in the AAA community is to take what we've built so far and make it super easy to work with. So, it's a one-click install for an image server, which is free and performant.
Right. Now, it does have implications, perhaps, in that one of the things that the American Art Collaborative is looking at and would like to achieve is to build and publish a rich amount of data, linked open data on American art. So we're talking about in-depth information in some cases, curatorial notes, videos, in addition to the collection data. But what you have shown is, as you said, is a minimal amount of information. So probably we would need a way, if this was something we wanted to pursue, to differentiate somehow a metadata version that's more label information, would you say? I don't know, maybe I'm incorrect, in order to harmonize with what your group is doing.
Yeah. So, yeah, the process that we have used so far is indeed not to create this directly. Instead, we take what already exists, or such as CRM for the British Museum or the Yale Center for British Art, and use that information to produce the presentation API. So we're not trying to say you should do it our way for everything, but instead we'd like it to be the way that the viewers interact with the content, so that it's really easy to build these performant interfaces. So yeah, indeed, have as much rich information as possible in a semantic way that can be reasoned about or searched or other sorts of features, but also take that, use the curatorial skills of the cultural heritage world to say, this is the information that is useful to people interacting with these objects. So instead of having perhaps all of the provenance information available about, it was bought at this time and previously it was there and then it moved to this room and then it was displayed at this exhibit. Instead, treat it as if you were building a virtual exhibition and say, this is what we need to have our users see. And so you're selecting from the rich descriptive information that you maintain, this is what is going to be useful to people to interact with.
Okay, thank you. Is Maren Lewis listening by chance? I'm just thinking what Rob has just presented in a way is very much a response to the question you posed about how do you access the information.
Yes, this is very interesting to me. So thank you very much for presenting it.
You're very welcome.
And I think there's some questions in the chat area for you, Rob. You see that?
Yeah. So Dwayne asked, the parameterized URL is interesting. Are there implications for the parameters if an institution creates a persistent URL through a Perl handle or DOI? Yeah. So let me quickly get back to that slide. So the base here can be as long as you want it to be. So that's where the Perl could go. So here at Stanford we have Perls that we call DRUIDs, Digital Resource Unique Identifiers. And our implementation simply puts that identifier into the base. Equally, ARC could be used there, or any other handle-based system. DOI is a little bit different because you need to use a particular DOI resolver that understood the parameters at the end, right? So if you went to dx.doi.org/10.1007/blah-blah-blah.jpg, you're going to end up going somewhere else from that DOI. So it's a little bit different in that regard because DOIs have a particular resolution mechanism that's already sort of baked into how they're used. But does that answer the question?
Yeah, thanks.
If you replied,
yeah, the DOI with the separate resolver will tend to throw away the parameters potentially because it doesn't have a way of handling them. So that was what I was wondering, and so it has implications on the rest of it. So yeah, that was perfect. Thank you.
Oh, good. And Emmanuel asks, can you elaborate a bit on how easy or hard it was to work with CRM and in the context of having to transform data from institutions that just have an API? Yeah, so I started with the British Museum's Sparkle endpoint and spent, so I know RDF and linked data pretty well. For someone who didn't know, this would be a different answer. So I started with the British Museum Sparkle endpoint and did a set of queries to pull out the information about the chess men. And to construct those objects. That took probably 2 or 3 hours to get the first part done, and then another 2 or 3 hours. So that was exploring the Sparkle, what information is available, and so on. And another 2 or 3 hours to massage it into the presentation API. So probably about a day's worth of work for someone who knows both the presentation API and how to interact with Sparkle. I then ran the same queries against your endpoint, and it didn't work, probably as expected, because the British Museum has a bunch of extension points, such as the main image that depicts the object is in something like px underscore main underscore representation or something like that. So then I had to change the interaction to go and get the equivalent information, even though it's still inside of CRM. The way that it's been used is different. So the graph traversal had to be modified a bit, but the base code was the same. Then the Fitzwilliam and the VNA have JSON-based APIs where they have documentation about this is how you do a search, and this is the results format that you'll get back. And yeah, then it's the same process all over again, where you have to first find out what the data is, figure out how to get to the bits of information that you need, and figure out what they're going to look like when they come into the transformation system. But then once you have it, the process is the same. You simply feed it through the code that builds out the presentation API. And that is typically only about 20 lines of code to build the presentation API. It's really very straightforward once you have the information collected. So I actually worked with one of the developers at the Fitzwilliam to improve their API. So, for example, they only had one image associated with each collection. So the Mali cuttings only had one image available in the API, but if you went to the website, you could see all, I believe there's like 100 of them. So they corrected that or improved that based on my feedback. And the VNA's interface is a little bit closer to linked data, and it would be great to be able to work with them to make it actually linked data, in that they have a very good concept of what a resource is. So this is an image is treated very separately from the thing that it depicts, and the sorts of information are very carefully managed. So they could probably generate either CRM or the presentation API very easily internally. So it's not that if everyone was using CRM, that everything, you'd only have to build a transformation engine once, unless everyone is using the same profile, the same set of properties in CRM. Is that a good explanation, Emmanuel?
Yeah, it's great actually, and it's good to get feedback from somebody who has actually used our Sparkle endpoint. So the takeaway point here is document it better. But it's really impressive actually.
Thank you. Anyone else? Was there any further questions? I realize we're at the top of the hour.
Yeah.
Well, Rob, I don't know if anyone else is. There's nothing in the chat room. It gives us a lot to think about, and it's really an important sort of breakthrough for us of how we might think of proceeding. So thank you very much.
Very welcome.
I think we need. I would like. I hope in the near future we could convene a meeting of the advisors to sort of talk through next steps. So thank you again for this. And I just wanted to remind people that I think it's November, am I right? 24, we have a presentation on the DPLA. And then in December, is it November 24? No, wait. I don't want to confuse you, but
Yes, it is the 24th.
yes, it is the 24th. Okay. And then on December 10th, Dominic Oldman on Research Space, which of course both DPLA and Research Space represent aggregation models, you know, which will be interesting to hear about as well. Rob, any final words?
So thank you to Diana and Dawn. Sorry, you're very welcome to Diana and Dawn. And if anyone has any comments or thoughts or questions that come up later, please do send me an email. I will be very happy to answer them. And if this is something that you think your institution might be interested in, we'd be ecstatic to have you join the AAA community and be excited to help you, get on board and start making content available in an interoperable way.
Thank you.
Oh yeah, and another plug for my colleagues at MCN for those attending. There's an hour and a half slot, which will be another opportunity to see how this works and ask questions and interact with other people in the community.
Okay.
Thank you all.
Signing off then. Thank you, everyone.